Launched in the 1970s, NASA's Voyager probes are still drifting through deep space, decades past their original mission. Now nearing the end of their journey, they remain silent sentinels of human curiosity, carrying our message to the stars. The birth of the Voyager. NASA launched the Voyager space probes during 1977 to achieve a mission which revolutionized our understanding of celestial bodies. NASA launched Voyager 1 and Voyager 2 in quick succession that year for the joint purpose of examining outer solar system planets before venturing through unexplored domains of interstellar space. NASA launched Voyager 1 for Jupiter and Saturn surveys, while Voyager 2 obtained a multiplanetary destination that consisted of Uranus and Neptune. These spacecraft expanded beyond their primary mission to become the most remote human creations which carried exploration beyond the stars as our star-fired envoys. The Voyager spacecraft reached its destinations because an extremely scarce planetary alignment appeared once at the rate of 176 years. The planetary alignment enabled these probes to execute gravity assist maneuvers through which they gained speed from each planet's momentum as they traveled across the solar system. Tracking the massive worlds, Voyager obtained new photographs of storm formations and volcanic planetary features and thin ring patterns. The spacecraft carried research instruments which collected extensive data that dramatically transformed our comprehension of outer planets and their lunar bodies. Both Voyager spacecraft continued their operations when they finished exploring the outer reaches of the solar system during the early 1990s. The scientific mission continued as NASA decided to maintain operation instead of retiring the spacecraft during this period of boundary exploration between solar fields and interstellar fields. The Voyager interstellar mission formally started a mission that would extend for numerous years to investigate the heliosphere border and adjacent fields. The Voyager twins transformed into cosmic emblems of exploration after NASA chose to maintain power on both spacecraft instead of ending the mission. A new frontier in space. Exploration, both Voyager spacecraft achieved a milestone through interstellar space in 2012, with Voyager 1 before Voyager 2 joined it in 2018. These historic achievements demonstrated both space exploration milestones and a fundamental human achievement by establishing a human-made object in interstellar space beyond the solar system. Both spacecraft needed to pass the heliopause before arriving at interstellar space, because this boundary separates the solar wind from unfettered galactic energies. Space inside the heliosphere presents a relatively familiar environment because it exists inside the protective bubble of charged solar particles. While the heliosphere exists as an initial border, it remains surrounded by the dangerous and unknown interstellar medium, which takes its shape from distant stars and their supernovae explosions and galactic magnetic fields. The probes obtained the role of our exclusive link to the unknown regions of interstellar space upon their entrance into this foreign domain. The probes have conducted tests to monitor interstellar plasma density, along with cosmic ray intensities and magnetic field analysis of this unexplored space region. Keep in mind that the data Voyager transmits serves as both an unprecedented discovery and an unreplaceable commodity. The Voyager probes remain the only spacecraft that successfully traversed this distance, while no other mission might make such a journey for many years. The pioneering work accomplished by their mission faces increasing difficulties. The instruments run on radioisotope thermoelectric generator systems that extract power from plutonium decay heat. The space probes experience yearly power degradation of 4 watts, but NASA scientists had to disable unimportant systems along with some scientific devices to save energy. NASA maintains only 3 instruments operate from the initial 10 space tools discovered on each probe mission. The power systems require another 1 or 2 years before the end of their capabilities, according to engineering assessments. Still, the Voyagers persist. The probes maintain their existence in the chill loneliness because they reflect human innovation alongside human strength, together with our eternal curiosity for unfamiliar territories. Missions harshed reality. NASA history holds no parallel engineering achievement to the maintenance of spacecraft, first launched during the 1970s, over 5 decades ago. The systems aboard Voyager were designed during an era when smartphones, along with the internet and modern laptops, had not been invented. The 4-decade-old spacecraft functions using outdated equipment which runs memory storage comparable to the space on a greeting card playing a sound signal. Only a tiny fraction of living people today can comprehend the machine code instructions running the outdated software which powers the spacecraft. From its launch in 1977 until this day, project scientist Linda Spilker has been a part of Voyager as she began her work at the start of her career. The Voyager team, together with Spilker, must constantly make painful selections about what instruments will stay operational, as each communication signal weakens and another system must be powered down. This mission goes beyond engineering work because it became an integral part of the team members' personal lives. The systems currently operate with engineers who retired or passed away long ago, while remaining crew members find the spacecraft to resemble deceased colleagues and retired team members. The extreme distance from Earth makes Voyager's analysis process exceptionally challenging. A one-way signal transmission requires more than 20 hours at present, so conversations between Voyager and Earth become extended over nearly 2 days. Engineers must handle problems that appear by turning to aging recorded documents consisting of both manual schematics and technical papers from before digital storage systems existed. Engineers who have retired from work return to the mission to provide valuable information beyond what manuals include. NASA scientists from the new generation learned the historic knowledge while developing contemporary solutions for maintaining space exploration. Each repair, along with the adjustments, represent complex operations that require engineers to manage the relationship between power conservation and data protection and preservation of the historical installation. The mission continues through each transmitted byte, while Voyager survives by using its limited power reserves, training the next generation of Voyager Guardians. NASA rushes to save decades of mission understanding because the Voyager team members and primary engineers are both leaving through retirement. Over half of the personnel who worked to construct the Voyager spacecraft in the 1970s have passed on from work life or are way past their working years. NASA maintains mission operationality through the combination of retirees who return part-time work and young engineers who take over former positions. The addition of new staff brings contemporary expertise into the organization, yet their assimilation process requires significant training. The onboard technology on Voyager operates on systems that modern engineers, using digital technology, would find completely unrecognizable. Most engineering programs have discontinued the teaching of machine code. Therefore, training involves extensive study of outdated programming languages and ancient mechanical systems. The work demands both computer knowledge combined with strong feelings. Current engineers at Voyager demonstrate their extensive experience through mentoring trainees by sharing their vital skills together with the mission's profound heritage. Such cooperative efforts between engineers will secure Voyager's remaining operational years and preserve its important legacy for the future. NASA conducts scientists' training to handle the data stream that continues arriving from the spacecraft. The meaningful scientific output of Voyager persists, even though its power is running low. Yet, future scientists need to understand how to analyze and utilize its findings. The mission approaches its scheduled conclusion, yet its scientific effects will impact the future generation of scientists throughout many years ahead. Voyager's endless influence. The Voyager mission provides endless scientific value that is impossible to measure. Its scientific discoveries at Jupiter and Saturn initially, and its ongoing observations in interstellar space resulted in new textbook information. One of its most significant achievements was revealing that Titan possessed an atmospheric layer as thick as a smoggy haze. The haze blocking Voyager's view of Titan's surface led directly to the planning of the Cassini-Huygens mission, which successfully landed on the Moon. The characteristic pattern of exploratory science manifests through each new discovery, which generates another significant scientific question. The mission remains alive for Linda Spilker, who spent 3 decades on Cassini before returning to work on Voyager, because she views it as a permanent string of cosmic inquiries. Voyager's famous pale blue dot image, Earth as a speck in the vastness, remains one of the most powerful reminders of our place in the universe. As these probes extend their journey deeper into space, they create numerous open inquiries behind them. The Sun can extend its power across what entire distances? Beyond its present position, what discoveries exist inside the following interstellar bubble that extends from the heliosphere? Scientific experts envision constructing the next generation interstellar probe because they want to continue Voyager's exploration journey.